Hey, geometry students. Today I want to go through and review congruent triangles and then take a look at the properties of our quadrilaterals. So here are your tasks today. 1, watch this video. Okay. 2, go back and finish unit unit 2 work on my open math. Okay. I want to be able to have you earn those points. It'll be a good review for Friday when we test on congruent triangles again and in applying the properties of our quadrilaterals. Okay, so the first thing I am going to do is review our 5 um, cases, 5 situations of congruent triangles. So the first is side-side-side congruence. So this is when I have 2 triangles, okay? And let's say we have triangle top and triangle hum. I don't know, I'm making stuff up. But I like to use letters that spell actual words, okay? So if we know that TO is congruent to HU, and if we know that TP is congruent to HM, and if we know that OP is congruent to UM, then I can make the claim that triangle TOP is congruent to triangle HUM because of side-side-side congruence. That's my claim. This is my evidence. This is my reason. My claim, my triangles are congruent or not congruent, as the case may be. How I know that, and the congruency theorem that backs it up. Okay, so that's case 1 is side-side-side. Case 2 is side-angle-side. So again, let's get some triangles here. So maybe I have one that looks like this, something like this. Let's see if I can stretch that. I don't know if it's going to let me. Let's delete that. It won't let me delete. Okay. Cut that out. Maybe it won't. Okay, anyway. Let's assume those are the same size. Maybe I can, like, there we go. That's better. All right. So I am going to name this SAME. So if I have side angle side, I'm going to have something like SE is congruent to SA. I'm going to have angle A and angle E, or angle SAM, congruent to angle SEM, and then EM congruent to AM. In this setup, we have side, angle, side congruence. So again, here's my evidence. Here's my claim. All right. Triangle SAM is congruent to triangle SEM. And my reason, by side angle side similarity. Now you may say, hey, Mrs. Miller, isn't there another way to do that too? Isn't SM congruent to itself? And the answer is yes, this is congruent to itself. So ultimately we have 3 options. I could instead say SM is congruent to SM, and then I would use side, side, side congruence. So this is really going to boil down to what you observe, how you observe it. What does your evidence tell you? Is it in the order of side, angle, side? Is it in the order of side, side, side? Is there more than one option? Yes. We all have different perspectives. We all see things in different ways. Both paths are completely acceptable. Both paths justify our claim that our two triangles are congruent. Okay? So let's take another look at scenarios 3 and 4. I like to group these together because this is another one where usually it's another like double perspective. Actually, I want to change that. I want to try to get my lines parallel. Yeah, there we go. That's better. So I want this line to be parallel to this one because that's going to give me some information. 5, let's see. All right. So my evidence here might be um, IG is congruent to GR. Okay. So that's given information. Then I know that TI is parallel to ER. Okay. That's given. Marked on my diagram, right? If I have parallel lines, then I can start to explore congruent angles. And you may say there's a couple of different congruent angle pairs we can use. And that's going to be how we observe from here will determine if we are going to use this method or this method for claiming my triangles are congruent. Okay, so my parallel lines give me my alternate interior angles congruent. So I can say angle TIG is congruent to angle ERG because they are alternate interior angles. Okay, and then you might also then see our vertical angles. So I can say angle, oh, I already put the angle symbol. Let's get rid of that. We don't need two of those. Angle IGT is congruent to angle RGE because we have vertical angles. So now if I'm looking at my diagram, we are going in the order of angles along the included side to another set of angles. So that's our angle side angle setup, right? So I can say triangle TIG is congruent to triangle ERG. That's my claim. And my reason is angle side angle congruence. But there is another path we can take. Instead of using vertical angles and using angle side angle, we have another set of alternate interior angles. So I could potentially say the angle ITG is congruent to angle REG, again by alternate interior angles. And this is all going to boil down to our perspective. And if we do this, that's a pair of angles, and then the side. So if I follow my path this way, that leads me to our angle side angle. I'm sorry, angle side congruence. So this is an example where how we view things impacts the outcome. It doesn't change the outcome, it just changes our approach to get there. Okay? So whether you are team a vertical angle or team double alternate interior angle, it doesn't matter because our triangles are congruent and your path determines, so whether it's this angle side angle path or if it's the angle angle side path, as long as your evidence matches the path you have listed and the reason you use at the end, doesn't matter. Okay? Our last scenario is hypotenuse leg. And this is the one we use only for right triangles. So let's say I have some right triangles here. Here, let me move that line. See if I can't get this to line up better. Something like that. Okay, so if I know I have right triangles, let's see, T, Y, P, E. Okay, so I am going to say TY is congruent to PY. I'm going to give you that information. So TY is congruent to PY. And triangle TEY and triangle PEY are right triangles. Okay, so that's our given information. If I have right triangles, remember that means I have two right angles here. Okay, what else do we see in our diagram? Well, you may see that we have a shared side. So I can say EY is congruent to itself by the reflexive property or shared side. Okay, so now this gives me the one and only case where angle side side works. And that spells a bad word, so we don't swear in geometry, so that's why we use hypotenuse leg. And the reason this works is because if I know two of three sides of a right triangle, I know the third side by Pythagorean theorem. But I don't want to do the Pythagorean theorem every time, right? That's kind of a waste of time. So we are able to use hypotenuse leg. So triangle TEY is congruent to triangle PEY by hypotenuse leg. Okay, so that's my reason. This is my claim. This is my evidence. Okay, now let's review some properties of quadrilaterals. So if I have a parallelogram, and this is how I write parallelogram without actually writing the word parallel, because remember, that's our symbol for parallel. Okay, looking at our properties, and remember we had our interactive Google document that we used to write down our characteristics. We know that a parallelogram, by definition, has two sets of parallel sides. And then we have additional characteristics. Those characteristics are not only are my opposite sides parallel, but they are congruent. And this really boils down to using congruent triangles. If I divide this parallelogram in half, do you see this diagonal is in both of these triangles? I get some alternate interior angles congruent, and my other set of alternate interior angles congruent. Then I have angle side angle. So that means the corresponding pieces of my triangles are going to be congruent to each other. That's definition of congruence. So opposite sides parallel. Oh, hold on. Opposite sides parallel. opposite sides congruent, because that follows from being able to divide my parallelogram into two congruent triangles. Okay? My opposite angles are congruent, also because we can divide into two congruent triangles. Okay? Because our opposite sides are parallel, my consecutive angles are supplementary. That means they add up to 180. Okay? And my diagonals, if I draw in the other diagonal here, they bisect each other. They cut each other in half here. Okay? And all of these are a result of congruent triangles. Okay? What changes if we have a rhombus? Okay? So if I have a rhombus, okay, the only thing that changes is a slight shift in the definition. It is a quadrilateral with 4 congruent sides. So all 4 of these sides will be equal. So what happens when I divide this into 2 triangles? We end up with 2 congruent triangles by side congruence. And this tells me a number of things. 1, I can get my alternate interior angles congruent because of a result of those corresponding angles, or I'm sorry, congruent triangles. And in fact, my opposite angles are bisected. That means they're cut in half. Okay, so my opposite sides are parallel, and that means everything up above is true, because this means it's a parallelogram. Not only do my diagonals bisect each other then, but in this case, they are also what we call perpendicular bisectors. So they are cut in half, and they form 4 right angles in the center. Okay, so diagonals are perpendicular bisectors of each other. So they cut each other in half. And the diagonals bisect the opposite angles. Okay? And this all follows from congruent triangles because I can match up those corresponding parts. The congruence means they totally map onto each other, right? Everything matches up. What changes for rectangles? What changes for rectangles? Well, let's look at a rectangle. Definition of rectangle: 4 right angles. A quadrilateral with 4 right angles. Now, if you look at this, this means my consecutive angles are supplementary. If consecutive angles are supplementary, my opposite sides are parallel. So opposite sides are parallel. That means this is also a parallelogram. So everything that's true about a parallelogram is true for a rectangle, plus more. Okay? So in a rectangle, when I divide into 2 triangles, all right, we've got 2 right triangles, And then I can even go so far as to look at what we call overlapping triangles. I can look at this one, right? And I can look at this one. I know my opposite sides are congruent because of the parallelogram. They share this side and they have the right angles. So I have side angle side congruence here. This tells me my diagonals are congruent. Okay? The diagonals are congruent. So all the properties of a parallelogram and then the congruence factor. What changes for a square? Well, that's a terrible square. All right. For a square, not only does it have the 4 right angles, but it also has the 4 equal sides. So what's cool about a square, it has 4 right angles plus 4 congruent sides. So we just state that it is all the properties of a rhombus and all the properties of a rectangle combined into one. It's just that. Combine your rhombus list with your rectangle list, which means we also combine it with a parallelogram list, right? And that's our square. Okay. 2 more quick shapes. We have a trapezoid and a kite. To review. So our trapezoid, we have 2 different kinds. Well, there's lots of different kinds. There's a standard trapezoid, which is like this. Okay. Then we have what's called an isosceles trapezoid. Okay. And then there's such a thing as a right trapezoid. Oh, that's not what I wanted. Let's try it again. A right trapezoid has right angles. It has 2 right angles. This is a right trapezoid. It has 2, exactly 2 right angles. Okay? A trapezoid's definition is at least 2 sides parallel. It has at least one set of opposite sides parallel. So that means technically a parallelogram is a fancy trapezoid. Okay, so keep that in mind. Characteristics then, any 2 base angles, any 2 consecutive base angles, like along opposite bases. Okay, so angle 1 plus angle 2 is 180. Angle 3 plus angle 4 is 180. So just keep that in mind. For an isosceles trapezoid, again, you have that at least one set of opposite sides parallel, and you have a set of congruent legs. So here, angle 1 and angle 3 are actually the same. Okay, so I'm going to call them both angle 1 and then angle 2. So we have 2 distinct pairs of base angles congruent, and the others are still supplementary. So 2 sets of base angles congruent. And I should add in the word consecutive. Okay, so we have 3 trapezoids to consider. Okay, last shape, and then I will stop, is the kite. Our kite, all right, something like this. It's actually a terrible kite. All right, I'm trying to, a kite has, there, that's, well, all right. All right. So here, what I'm going to do is divide my kite according to the diagonals. So the definition is it has two distinct sets of consecutive sides congruent. So that means Ki is congruent to IT, okay? And Ke is congruent to Te, okay? Additionally, my diagonals, IE and KT, are perpendicular. And this longer diagonal, the one that cuts this into, like, you see we have two congruent triangles there because this is reflexive or shared side. I have one of each pair. The diagonal that creates the kite with one of each pair of congruent sides is the perpendicular bisector of the other diagonal. Okay? This longer diagonal also bisects the opposite angles. So side IE bisects angle KIT and angle KET. To bisect means to divide into two equal parts. So that means these two angles will be equal, and then these two angles will be equal. Okay? Those are the properties we need to know. So make sure you have everything filled in. Go back, finish your MyOpen Math for Units 2 and 3, and I look forward to seeing you tomorrow.